Space Telescope images of ISON. You can see this is an animation from the first set of images that were released from Hubble of Comet ISON. And when Hubble took these pictures, NASA stacked them in such a way as to eliminate the stars in the image. They did a median combine. And as you can see, they tracked the Space Telescope directly on ISON, on the comet, and the stars formed streaks. Now there's a bunch of streaks in this image. Most of it's cosmic radiation, cosmic ray hits. There are some stars, however, and you can see them as brighter, thicker streaks that taper off towards their edges. That's a point spread function. That's what stars do, and that's something that you won't see in cosmic ray hits. And you can see that they bend quite a bit. Some of these stars bend, especially right there towards the end. That one bends quite a bit, makes a sharp turn, and that's because of parallax during the course of Hubble's imaging of the comet. We previously took a look at this animation, where you can see the stars once again bending over the course of the animation, and once again the Hubble Space Telescope was tracking the comet directly and allowing the stars to streak. And if you put all the images together and you compare it to the expected parallax based on Hubble's orbit, you saw that it formed this wave function which matched what was observed perfectly. And so it was the same story here. It's a little more disjointed, however, because they shot these images over multiple orbits, which is why the stars suddenly seem to vanish, more stars appear down here, but they show that same parallax motion with a very sharp turn there. Now, in some of the latest images, if you stack all the images together, you get this V shape in the comet. Well, in these images, they've now tracked the stars directly and allowed the comet to streak. And so the comet shows the parallax instead of the stars. And you see this very sharp bend here forming this angle. So if we do the same thing again, and we take Celestia, and we load up the orbit for ISON, we can see that indeed that's what it should have done. That's the expected parallax angle formed by the comet. What I've done here is I've created an artificial star at the intersection of right ascension and declination grid lines, and aligned all the images on that star just as they tracked the stars while imaging the comet. And sure enough, the comet makes that angle. It takes that sharp bend and forms this V shape that was seen in the total stacked image. Now this is all the images stacked together. If you look at the individual images, it looks much more normal. In fact, let's take a closer look at one of the individual images that they shot. So this is an unstacked image, just a single image from that imaging session. And you can download all the raw data. I'll include a link in the video description. And if you zoom in on the nucleus of the comet, you can see it too forms a bend. It bends a little bit there due to parallax over the imaging. That's over the individual exposure. Now, the stars, once again, were being tracked on in these images, so they don't form lines and they don't bend during the imaging because they were guiding on the stars directly. So if you do the same thing in Celestia and you guide on your artificial star using the equatorial grid, you can see that ISON does indeed do exactly that. It forms that V shape. So that's quite normal and expected. Now the one deceptive looking thing here, if you look carefully, it looks like the tail of the comet is going to the right in these images from Celestia. That's just how Celestia is rendering it. It's kind of deceptive. I'm zoomed in here quite a bit because Hubble is zoomed in quite a bit on the comet. It's a very narrow field image, and when you zoom in that much on Celestia, you'll see that it's actually darker on the left side than on the right side. Now I've enhanced the contrast in those images you just saw from Celestia, but if you zoom out, you'll see actually the tail is to the left as it was in the actual image from Hubble. So that's that. Hi folks, another video here on Comet ISON and the Hubble Space Telescope images of ISON. You can see this is an animation from the first set of images that were released from Hubble of Comet ISON. And when Hubble took these pictures, NASA stacked them in such a way as to eliminate the stars in the image. They did a median combine. And as you can see, they tracked the Space Telescope directly on ISON, on the comet, and the stars formed streaks. Now there's a bunch of streaks in this image. Most of it's cosmic radiation, cosmic ray hits. There are some stars, however,